Hey guys, so this video is to help us with this particular I can statement. And the I can statement is to write the equation of a line that is either parallel or perpendicular to another line that's represented by given information. So in other words, you're going to be given a line and some information and asked to write another line, that's parallel or perpendicular to what you've been given. So let's give this a try. Hey guys, so this is the first example, and I'm not going to actually give you an example of a perpendicular line because I'm going to ask you guys to kind of do a little experimentation and see if you can't figure that one out for yourself. But I am going to help you out with the parallel. So this particular problem says write the equation of a line parallel to, and then they give us the line parallel to this line right here that goes through the point 110. Okay. So first thing we might want to do here is graph the line we're given just to kind of get an idea of what it looks like. So I'm going to simplify this into slope-intercept form. So y minus 5 equals 5x plus 5. I just distributed the 5 there. Now I have to add 5 to both sides, and so we end up with this equation, right? So our y-intercept is 10. So if I can get that on the 10, it's kind of hard to graph lines with this software, so I have to forgive the sloppiness. And then if I wanted to get another point, let me just plug in like -1 for x. So if x is -1, that would mean y would be 5, right? So we'll go up 5, 1, 2, 3, 4, 5. So I got a point there and a point here then. Okay, so this is essentially our line. Ooh, it's really hard to draw. I think that's sort of terrible, actually. Let me fix that arrow here. So that's close to a straight line, sort of. And we want to do something that's parallel to that, but that goes through the point 110. And 110 is right here. So that's the point 110. Right? And so you might have already figured out that if something's going to be parallel, it needs to have the exact same slope. Because if it doesn't slope the exact same way, then eventually it's going to run into the other line, right? And we've known from the beginning, actually, that our slope was this number right here, 5, right? Because we know that, let me erase this real quick. We know that this equation was given to us in point slope form. And point slope form is, if you remember, y minus y1 equals the slope times x minus x1. Or in other words, these guys right here are a point off of the line. And we're actually going to come back and use this to write a line that's parallel. And in fact, you don't even have to graph anything to solve a problem like this. I just graphed it so it could be maybe a little bit more visual. But really all you need to do is plug in the point that they give you. So minus 10 equals the slope, and we know the slope needs to be the same for it to be parallel. So 5 times x minus our x value, which is 1. So what I've done here is I've taken the point that they've given me, I put it into the point slope form, and then I've taken the exact same slope that they gave because I know that if a line is going to be parallel to another line, they have to have the same slope. So now I'm just going to go ahead and simplify this into slope-intercept form. So I'm going to have y equals 5x plus 5 is going to be my final form. And if you're wondering how I did that, I just distributed the 5 and then I added 10 to both sides. So this becomes the line that's parallel to the line that they originally gave us. So this is really our answer here. And in some particular problems, they may ask you to write the line, the parallel line in a specific form. We could change this to standard form or really any form we wanted. And as you can see, the y-intercept here is 5, which would be right about here, roughly, right about there. And that looks about right. These lines would be parallel. And so in general, well, really all the time, if two lines have the same slope but a different y-intercept, they're going to be parallel lines. But I'm going to ask you, what would happen if they had the same slope and the same y-intercept? And I want you to think about that. And then I want you to think about perpendicular lines. Let's talk about those for just a second. So really quick, I want you to think about the word perpendicular. And I want you to think about what would make a line perpendicular to another. So if we have this if we had this line here graphed like this, what would be a perpendicular line to the white one? Well, it would be a line that would intersect the white one here at a 90-degree angle. So you'd have 90 degrees here, 90 degrees here, 90 degrees here, and 90 degrees here, right? So it's got to intersect in a perfect fashion. It can't be 91 degrees, it can't be 89 degrees. It's got to intersect at a 90-degree angle. And for that, there's a specific slope. So let's say that the equation of our white line here was y equals x. Okay? So just a simple slope of 1, and the y-intercept is 0. So there's going to be a specific slope associated with the other line that will make it perpendicular to the given line. And that's what I want you guys to try and do, is experiment a little bit, graph your own line, come up with your own line and equation, and then try to find a line that would be perpendicular to the one you write. And then determine what does the slope look like? Try to find that pattern, because there is an answer to this. There is something you can do to the slope of any line to find the slope of a line that would become perpendicular to it. And that's what I want you guys to explore. And then come to class tomorrow with a few problems done. So you're going to do a few problems to write parallel lines, and then I want you to try and come in with this exploration, or do come in with this exploration of a perpendicular line, and be ready to explain to a partner what you think makes a line perpendicular to another, not just in the definition I've just told you, but specifically, what about the slopes of two lines would make them perpendicular to each other? All right, good luck, guys.